Hello. And I was going to say good morning, but good afternoon to wherever in the world you are joining us from today. We're glad you can join us for our live webinar called Impact of Two Formulations of Buprenorphine on Post-Surgical Condition in Mice. My name is Diane Ordonez from Columbia University, and I will be the moderator for this session. Today's educational webinar is presented by LabRoots, the leading scientific social networking website and provider of virtual events and webinars advancing scientific collaboration and learning. To learn more, visit labroots.com. Let's get started. You can pose questions to the speaker during the presentation while they're still fresh in your mind. To do so, simply type them into the Q&A box, which will open when you click the green Q&A button at the lower left of the presentation window. Questions will be answered at the end of the presentation. To enlarge the slide window, you may click on the screen icon on the lower right hand of the slide window. Should you experience any technical problems seeing or hearing the presentation, just click on the support button that can be found on the top right of the presentation window, or report your problem by clicking on the green Q&A button at the lower left of the screen. This is an educational webinar and thus offers free continuing education credits. After the webinar is over, please click on the CE button located in the bottom left-hand corner of your web page and follow the process of obtaining your credits. I now proudly present today's speaker, Dr. Nicole Herndon, who is a veterinarian currently at Columbia University Medical Center. She obtained her doctorate of veterinary medicine from Oregon State University, where she spent some time at the Oregon National Primate Center, including working in a Huntington's disease research laboratory. Following completion of veterinary school, Dr. Herndon began a 3-year postdoctoral research residency for veterinary laboratory animal medicine at Columbia University. While in this role, Dr. Herndon oversees the general animal care in the facilities, trains investigators on aseptic technique and surgical skills in rodent models, performs veterinary protocol review consultations, is an active participant in IACUC meetings, and has participated in site visits from the USDA, Department of Health, and ALAC. She also assists with the anesthesia monitoring of the USDA-regulated species. She completed a research project comparing mortality rates, selected inflammatory cytokines, and overall condition of mice administered buprenorphine sustained release to buprenorphine hydrochloride in a murine model for polymicrobial sepsis, the results of which were published in the Journal of Comparative Medicine in December of 2016. She will complete her residency in June of 2017. I now present Dr. Herndon, who will begin her presentation.
Thank you, Diane, and thank you all again for coming and listening to this presentation today. The purpose of this presentation is to discuss the use of two formulations of buprenorphine, standard buprenorphine or buprenorphine hydrochloride, and sustained-release buprenorphine, specifically in regards to surgical models in mice. We'll cover the analgesic effects of each formulation, compare the two in terms of analgesic effects, and finally end covering a study that compared the two formulations in a murine sepsis model. The learning objectives for this presentation are to identify the benefits and disadvantages of the use of buprenorphine, HCl, and sustained release in a murine model. Also, you should be able to describe methods to evaluate post-surgical condition in mice. For starters, why do we need to consider the use of analgesics in our animal studies? Aside from ethical considerations, there are several regulatory bodies that require the use of analgesics in animal procedures. The Health Research Extension Act of 1985 states that unless the contrary is known or established, it should be considered that procedures that cause pain in humans may also cause pain in other animals. The government principles for the utilization and care of vertebrate animals used in testing, research, and training states that procedures with animals that may cause more than momentary or slight pain or distress should be performed with appropriate sedation, analgesia, or anesthesia. The PHS policy states that animals used in biomedical and behavioral research are provided with appropriate treatment, including the appropriate use of tranquilizers, analgesics, and post-surgical veterinary medical and nursing care. Now that we've established the need to consider the use of pain medications in our studies, what analgesic options do we have? Listed here are some common analgesic agents that we see used in mice. Nonsteroidal anti-inflammatory drugs, or NSAIDs, such as carprofen, are often used because of their ability to alleviate inflammatory types of pain. They tend to have a longer duration of action than opioids, thereby requiring less frequent dosing. Some of the side effects of nonsteroidal anti-inflammatory drugs are gastric or intestinal ulceration, disturbance of platelet function, and changes in renal function. Opioids are used following procedures that are thought to cause more severe pain, necessitating the use of a more potent analgesia. This is especially true when there is a chance of deep or visceral pain stimulated during the procedure. Since this presentation is focusing on buprenorphine, we're going to delve into this analgesic properties a little bit further. Buprenorphine is a partial mu agonist and kappa antagonist. It has a lower abuse potential compared to other opioids, which may be in part due to a ceiling effect of buprenorphine. Increasing the dose of buprenorphine will increase its effect up to a ceiling, at which point the antagonistic properties predominate and begin to decrease the analgesic efficacy. It has a relatively long duration of action compared to other opioids as well. Some of the noted side effects of buprenorphine are pica, respiratory depressions, decreased intestinal activity, decreased heart rate, and sedation. There's been considerable data available on the dosage and efficacy of buprenorphine. Sustained-release buprenorphine, or buprenorphine SR, is a sustained-release injectable formulation of buprenorphine that was developed by a United States veterinary compounding pharmacy. There have been a number of studies that examined the duration of action of Bup SR compared with buprenorphine HCl. We'll cover a few such studies now. This paper from 2012 was written by Carbone and colleagues titled Duration of Action of Sustained-Release Buprenorphine in 2 Strains of Mice. This study used the hot plate assay to assess the anti-nociceptive effects of a single injection of buprenorphine, sustained-release, buprenorphine HCl, and saline over 72 hours in young adult Bulb C and SWRJ mice. This graph represents the maximum possible effect on the y-axis and time on the x-axis. This group noticed a significant difference between buprenorphine HCl and buprenorphine SR and the control at 2 hours, highlighted here, between Bup SR and saline at 6 hours and 12 hours, and also notice the difference between buprenorphine SR and buprenorphine HCl at 72 hours. What this study concluded was that there was a significant or a relative increase from baseline latency significant for buprenorphine SR, at 2, 6, and 12 hours. The analgesic efficacy of Bup SR lasted at least 12 hours in the male Bulb C and SWR mice. The next study we'll look at is from 2014 from Kendall and colleagues, titled Pharmacokinetics of Sustained-Release Analgesics in Mice. This study looked to determine the pharmacokinetics of sustained-release formulations of buprenorphine, carprofen, butorphanol, fentanyl, and meloxicam compared with the standard formulations of buprenorphine, carprofen, and meloxicam. Mice were divided into treatment groups and dosed the analgesic for that particular group. The plasma concentrations of the group are listed in these charts here. Significant differences were noted in buprenorphine, SR, and HCl at 4 hours, 8 hours, and they noticed a significant difference between carprofen SR and standard release carprofen at 4 hours. Finally, for meloxicam, the group noticed a significant difference at 2 hours, 4 hours, and 8 hours between the sustained release and the standard formulation. Specifically for the buprenorphine doses, this group found that buprenorphine SR plasma drug levels were greater than the therapeutic level for the first 24 to 48 hours. Also, plasma levels of Bup HCl fell below the therapeutic level by 4 hours. Finally, these results indicated that buprenorphine SR provided a stable plasma drug level adequate for analgesia for 24 to 48 hours after administration, whereas all other sustained-release formulations required additional doses to provide analgesic levels beyond 24 hours in mice. The last study we'll look at comparing the pharmacokinetic assessment of standard or sustained-release buprenorphine is from 2014 by Clark and colleagues, titled Pharmacokinetic Comparison of Sustained-Release and Standard Buprenorphine in Mice. This study compared different dosages for animals in either standard buprenorphine or sustained-release formulation, as well as a saline control group. Male C57 black 6 mice were provided with buprenorphine HCl, in this table labeled Bup IR, standing for immediate release, and Bup SR at the doses listed at the table. A buprenorphine ELISA kit was used to determine the drug concentration in the blood samples. This graph plots the buprenorphine concentration in blood of the different buprenorphine formulations over 48 hours. The upper horizontal dashed line represents the therapeutic threshold for buprenorphine. This study concluded that buprenorphine SR at 1.2 milligrams per kilogram and Bup HCl at 0.1 or 2 milligrams per kilogram achieved or surpassed the published threshold for adequate analgesia in mice. In addition, as the previous chart showed, 1.2 milligram per kilogram buprenorphine SR and 2 milligram per kilogram buprenorphine HCl provided blood concentrations above therapeutic threshold for up to 12 hours. Now that we've established that buprenorphine SR has the pharmacokinetics to last for an extended duration of time, let's look at some of the studies that compared Bup HCl to Bup SR for pain relief. This study was published in 2014 by Healy and colleagues and was titled Evaluation of an Improved Sustained-Release Buprenorphine Formulation for the Use in Mice. Mice were assigned to 3 treatment groups: a control, a dosing of buprenorphine HCl, or a dose of buprenorphine SR. Mice were evaluated to determine behavioral and physiologic responses at 4, 24, and 48 hours after treatment administration. The mice were evaluated for total activity, gastrointestinal tract motility, respiratory rate, cataleptic behavior, tail flick and hot plate nociception tests, and body weight. What Healy and colleagues concluded was that buprenorphine SR maintained anti-nociceptive effects for 48 hours for the hot plate and tail flick tests. The buprenorphine SR group had a lower respiratory rate compared to the control group. Buprenorphine SR had no significant changes in body weight during the study, whereas buprenorphine HCl mice had a significant decrease in body weight at 24 and 48 hours. In terms of the other parameters evaluated, the gastrointestinal tract motility and total activity were higher at 4 hours for mice receiving the buprenorphine SR than for mice receiving the vehicle, but the values were the same between the groups at 24 and 48 hours. This 2015 paper by Jurkov and colleagues, titled Buprenorphine for Pain Relief in Mice, Repeated Injections versus Sustained-Release Depot Formulation, sought to compare the sustained-release formulation of buprenorphine with a standard protocol of 3 injections of buprenorphine in female mice undergoing a laparotomy procedure. Female C57 Black 6 mice underwent a one-sided sham embryo transfer for their surgery. The following methods were used to test the analgesic efficacy: serum concentrations of buprenorphine, thermal sensitivity using a hot plate, and ethological measures of pain and recovery, including body weight, food and water intake, burrowing behavior, and an ethogram score. An ethogram is a catalog or table of all the different kinds of behavior or activity observed in an animal. Ethograms have been described from many species, and the one shown here is specific for mice. By assigning numeric values to the scores, a scoring system can be established in efforts to provide more objectiveness to a subjective situation. This particular ethogram was used by Jerkoff and colleagues to quantitatively evaluate the clinical condition of their mice. Jerkoff and colleagues found that the mice dosed with Bup HCl had serum concentrations and thermal sensitivity tests for a duration of at least 4 hours, but less than 8 hours. The animals dosed with the buprenorphine SR had a duration of action of 24 to 48 hours. Behavioral and clinical parameters indicated at least partial pain relief after surgery for both protocols. This group indicated that an application interval of 8 hours for buprenorphine HCl appeared too long and might lead to repeated periods with insufficient analgesia in animals undergoing lasting or substantial pain after surgery. In comparison to the standard protocol, the buprenorphine SR provided a long-lasting, assured analgesia without possible stressful repeated injections in a standard surgical model with only limited and acceptable behavioral side effects. The next study came out in 2016 by Kendall and colleagues. It's titled Efficacy of Sustained-Release Buprenorphine in an Experimental Laparotomy Model in Female Mice. This group sought to determine the clinical efficacy of Bup SR at 0.6 milligrams per kilogram for 72 hours after an experimental laparotomy in female CD1 mice. Female CD1 mice underwent laparotomy procedure and received either buprenorphine SR, dosed at 0.6 milligrams per kilogram, buprenorphine HCl, dosed at 0.1 milligram per kilogram every 12 hours, or saline, given at every 12 hours. Pain was assessed at varying time points according to the frequency of several behaviors. These behaviors included general activity, wheel running activity, rearing behavior, grooming, wound licking, percentage of integrated nest material, body weight, and orbital tightening. Orbital tightening is one of the components of a mouse grimace scale system described by Langford et al. Orbital tightening is the narrowing of the orbital area with a tightly closed eyelid or an eye squeeze noticed by wrinkling around the eye. This figure on the slide here comes from the Langford paper titled Coding of Facial Expression of Pain in the Laboratory Mice. While Kendall and colleagues did not utilize a full mouse grimace scale system as described by Langford, they were able to isolate a component of the scoring system to better evaluate the post-operative pain in their mice. Going back one slide to discuss the other parameters that the group measured. The wheel running activity was known to be increased and wound licking decreased over time in mice that were dosed with buprenorphine SR compared to mice dosed with buprenorphine HCl and the saline control mice. Buprenorphine SR mice had an increased general activity and percentage of integrated nest material, as well as decreased orbital tightening for 1 to 6 hours after surgery compared with the buprenorphine HCl and the saline-treated mice. In general, the buprenorphine HCl and saline-treated mice had similar general activity, orbital tightening scores, and wheel running activity. From their results, Kendall and colleagues concluded that buprenorphine SR at a dose of 0.6 milligrams per kilogram provides adequate analgesia after laparotomy in mice. Buprenorphine HCl at a dose of 0.1 milligram per kilogram every 12 hours may be inadequate for providing analgesia for abdominal procedures in mice. The previous studies we covered were able to compare pain relief of buprenorphine HCl and buprenorphine SR. However, there have been fewer studies examining how buprenorphine SR may have an effect on different research parameters. The next paper attempted to compare the effects of Bup SR and Bup HCl in a commonly used research model in mice. This research, titled Sustained-Release Buprenorphine Improves Post-Surgical Clinical Condition but Does Not Alter Survival or Cytokine Levels in a Murine Model of Polymicrobial Sepsis, was conducted by myself and colleagues with the goal to determine the effects of buprenorphine HCl compared with buprenorphine SR on several parameters in mice undergoing a cecal ligation and perforation procedure. Clinical condition, plasma concentrations of monocyte chemoattractant protein 1 and interleukin-6, and overall mortality were measured in efforts to determine the post-surgical condition in these mice. Male C57 Black 6 mice underwent a CLP surgery performed by the same surgeon who was blinded to all treatment groups. Mortality was recorded at every time point mice were examined. Inflammatory cytokine levels were measured at 24 hours post-CLP procedure. Mice were observed twice daily for the clinical condition scoring by the same blinded investigator. The evaluation of the post-surgical condition consisted of an ethogram with parameters consisting of movement, posture, interaction with conspecifics, response to cage opening, and response to handling. The time to integrate to nest test was also performed on all animals undergoing the CLP procedure. Finally, nest scoring was performed every day post-CLP procedure. This figure comes from Gaskell and colleagues' paper titled Nest Building as an Indicator of Health and Welfare in Laboratory Mice, and represents a standard nest scoring system. The standard nest scoring system is on a scale of 0 to 5. A score of 0 represents an untouched nesting material. A score of 1 represents the nesting material is spread throughout the cage with no discernible nest site. A score of 2 is that the nesting material has been made flat with no shallow walls. A score of 3 is a slightly cup-shaped nest where the walls are less than half the height of the dome. A score of 4 is a wall that is half the height of the dome. And a score of 5 are walls that are taller than half the height of the dome, which may or may not fully enclose the nest. The results of this paper show that there was no significant difference in the cytokine levels MCP1 or IL-6. There was also no significant difference in the mortality between the animals dosed with buprenorphine HCl or buprenorphine SR. There was a significant decrease in the behaviors associated with perceived pain at 12 and 24 hours postoperatively in the mice in the buprenorphine SR group compared with the buprenorphine HCl group. Neither group was noted to build nests following the procedure, and neither group were tint positive during this testing. This is a visual representation of the inflammatory cytokine serum levels and the mortality curve noted in this study. As previously indicated, here in figure A, the MCP1 levels showed no significant difference between the Bup HCl and the Bup SR mice. Figure B shows the IL-6 serum concentration levels, and again, there was no significant difference between the Bup HCl or the buprenorphine SR mice. As previously stated, there was no significant difference in either mortality between the two groups. This is a representation of the clinical condition scoring with the ethogram results displayed here. Figure A shows the clinical condition scoring 12 hours post-CLP procedure. There were significantly fewer perceived behaviors of pain at 12 hours, as noted in this chart. Figure B shows the clinical condition scoring at 24 hours post-CLP procedure. And again, there were significantly fewer perceived behaviors of pain at this time in the buprenorphine SR group compared with the buprenorphine HCl group. Figure C represents the clinical condition scoring at 36 hours post-CLP procedure. At 36 hours, the condition scores were not significantly different between the two groups. Because of the lack of significant effect on MCP1 and IL-6 levels and the mortality and the superior analgesic effects of buprenorphine SR, my colleagues and I recommend the use of buprenorphine SR for analgesia during the murine CLP model of sepsis. Also, due to the clinical condition of animals in the buprenorphine HCl group, we recommend more frequent dosing than every 12 hours for animals undergoing a CLP model of sepsis. This slide provides a generalized outline of some of the benefits and disadvantages of the use of buprenorphine HCl and buprenorphine SR. As the studies we've gone over have indicated, there is a need for more frequent dosing with the buprenorphine HCl compared to that of the buprenorphine SR. This means that researchers would be able to physically see their animals at the times of buprenorphine HCl administration, which could be more frequent than those animals dosed with buprenorphine SR. Although not mentioned specifically in this discussion, there are more studies that show buprenorphine has little effect on some parameters of research, such as inflammatory cytokines. Such extensive research is not yet available for buprenorphine SR at this time. As these studies have shown, buprenorphine SR has reported analgesic effects lasting greater than 12 hours. This equates to less frequent handling and potentially less stress caused to animals from the increased injections required with buprenorphine HCl. In general, some side effects of opioids include weight loss and pica, as well as increased lethargy or sedation. This increased lethargy and sedation has shown to have an effect on the scoring of NEST as well as TINT scoring in some studies and should be considered when evaluating postoperative pain in mice. So what should we expect to see in the future? In regards to sustained release formulation of buprenorphine, I would expect to see more studies examining the effects with other common research procedures, as well as studying the effects on other animal species. As other extended release formulations come out, pharmacokinetic studies as well as studies on effects in research are expected to be seen. I would like to say thank you to the Columbia University Medical Center, as well as the lab members who helped me with my paper, Sheila Bandiopadhyay, Kevin Prestia, and Eldad Hod. I'd like to also thank Diane Ordonis again for being the moderator for this presentation, and I would like to thank LabRoots for giving me the opportunity to speak about buprenorphine SR as well as HCl in a post-surgical condition in mice. These are my references, so feel free to use those when looking at the different buprenorphine formulations. And at this time, I'd like to open up the floor for any sort of questions or discussion.
Well, thank you very much, Dr. Herndon, for your presentation. And just a quick reminder for our audience on how to submit questions should any strike you. Simply type them in the Q&A box, again, found by clicking on the green Q&A button at the lower left of the presentation window. And Dr. Herndon will answer as many questions as time permits. So the first question we have here is, have you noticed Bup SR causing wounds at the injection site?
In my particular study, we did not notice any wounds at the injection site. And I know that in one of the other studies mentioned, they did not notice any gross wounds at the injection site as well. I know in other species that has been one of the concerns, but in the mice models that I have used, I have not noticed any injection site reactions.
Okay. In your studies in particular, were both HCl and SR given every 12 hours? And if so, for how long? And I believe it's in reference to the duration of days.
Right. So that's a good question. For the HCl, we dosed every 6 to 12 hours, as that followed the pre-approved IACUC protocol we were following. So for the initial 2 days, for the initial 24 hours, we gave a dose every 6 hours, and then we waited 12 hours to the following day, and then did another every 6-hour dosing for a total of 6 doses over 2 days. The SR was just given once at the start of the procedure, and yeah, that was the extent of the dosing that we gave for our buprenorphine HCl and buprenorphine SR.
Okay, and did you notice a time difference between the analgesic effect between the SR formulation versus the hydrochloride formulation?
So the big analgesic effect we saw was that overnight time span. So the doses were given, if I were to give an actual timeline, the HCl was given at time of surgery, so 7 or 8 o'clock a.m., and then again at noon or 1, and then again at 6 or 7. And then we went overnight to go and give another dose at 7 a.m., which was the 12 hours. That was probably the biggest effect that we saw, was that 12-hour stint between the HCl and the SR dosing. By 48 hours, we had reached a 50% mortality in our sepsis models, which was to be expected. And at that point, we didn't notice any difference in the analgesic because our mice had started to succumb to the septic state that we had induced.
Okay. Have you noticed any incidence of pica in the mice under Bup SR? And to take that in conjunction with another question, are you aware of any reports of pica in mice versus rats with the SR formulation? If you're aware of any of the literature or knowledgeable about that region or area.
So in our study, we did not notice any pica in the mice that were dosed with buprenorphine SR. I don't recall seeing pica listed in SR in other research models, but I haven't seen all the research, I'm sure, but I have not come across that. I'm sorry, what was the second part of that question again?
The second part of the question that was posed was whether or not you've noticed or if you came across any articles related to pica of the SR formulation in mice versus rats.
I have not looked into SR in rats as extensively as the mice, so I don't have an answer for that particular question. I'm sorry.
Our next question is whether or not there have been studies looking to other analgesic agents aside from buprenorphine, specifically in sepsis studies.
There have been studies that look at other analgesics in sepsis studies. There's been studies looking at tramadol as well as some other analgesics that I'm not quite familiar with at this time. But for the most part of these studies that I've researched, the buprenorphine seemed to have the most minimal effect on sepsis studies in regards to mortality and inflammatory cytokines that were looked at.
And in your opinion, do you feel that that was adequate analgesic coverage, the buprenorphine alone?
Personally, I feel that if the buprenorphine was given at a more frequent dosing, so not going beyond, I would probably say 6 to 8 hours, it would suffice for the sepsis studies. It just needs to make sure that we give it frequently enough so that the concentrations of buprenorphine stay in the system so the animals don't become painful.
Okay. And I have just a few more questions here. I'm trying to consolidate them into one question. And it looks like this one isn't directly related to the analgesia regimen that was employed or talked about in this presentation, but more related to the animal model that you used. So the question posed is, what methods have you used to confirm the animal disease model? So I believe this is in reference, and please correct me if I'm wrong, to the cecal ligation and puncture and perforation model itself.
I'm sorry, can you repeat the question?
So the question is, what methods have you used for confirmation of animal disease model? And from the way I interpret it and the way that I'm reading it, it seems that the question posed is, what methods have you used to confirm that CLP is more or less, as the literature would state, the gold standard of polymicrobial sepsis?
So the CLP study has been performed for a number of years and has been proved in other studies as the gold standard model for sepsis research. There's other studies that are recommend an injectable form where you would actually inject bacteria into the intraperitoneal space to induce a septic state. Both of those models are very common in literature. I think the main thing is not just historical, but there have been other studies specifically done to prove that this is a gold standard model of sepsis. I personally did not perform any other models for sepsis.
Okay, thank you. And it looks like I'm getting the trickle. Oh, no, I have other questions. Just a second. Have you used transgenic mice models when comparing Bup SR to the regular buprenorphine?
Personally, I have not. And it's something I would go ahead and look into other literature for. We were focusing mostly on what another lab was using, and we were using their models in order to study the sepsis and the best analgesic we could provide for these mice.
And could you comment just briefly on the efficacy of the dosage that you used in this study, or in your particular study?
Here, let me pull that up. The dosage that I used, as I pull that up, it was efficacious. The animals had much better clinical condition scores versus the animals that were given the buprenorphine HCl. And we gave a dose of 1 milligram per kilogram subcutaneously.
And actually, as a follow-up to that, this is a very nice question. Are there other ways to see that an animal has moderate pain or not, aside from the behavioral scoring that you performed in your study?
So behavioral scoring is becoming bigger and bigger, so that is a really good way to assess their pain. Other ways that there's other ethogram scores out there that assess different parameters. So one of the papers I mentioned here included a rearing behavior, so being able to stand up on their hind limbs, wheel running activity, and one of the other big ones that are out there are either the building of the nest, so doing a nest scoring, or the tint scoring, which I briefly mentioned, and I didn't go into great detail here, but that's basically where you have an animal that's already built a nest, a good nest, and then you add a portion or nesting material to the opposite side of where that nest is, and you see if they incorporate that portion of nest that you've added to their home nest within, I think, a 10-minute time span. And if they do, that means that they're of a more normal sense. It's a binary scoring system. But that's one of the bigger ways with nest scoring. Some people will also do weight loss or food and water consumption. Just note that if you're doing a surgical model, that animals may lose weight due to surgery and not necessarily due to pain. And there's probably other methods out there, but those are the big ones that I can think of.
Excellent. And this last question that I have here is more of not a theoretical question, or maybe in your experience. I know earlier you alluded to not having performed work in transgenic mice, but this particular question refers to whether or not you would anticipate seeing differences in analgesic efficacy in different mouse strains.
So there have been different studies that we mentioned here today that use different strains, such as Bup C mice or the Black 6 mice or CD1. And of those studies, a lot of them reported very similar findings in that the efficacy, the SR seemed to work well. It's one of those questions that you'll never know until you find one strain that is different. But for the most part, you may see some minor effects, but hopefully the opioids would be able to cover any sort of significant procedures that may cause significant pain.
Okay, our next question. You are quite popular today, Dr. Herndon.
Yes.
What is your opinion on giving buprenorphine prior to the first incision versus giving it at the time of incision closure?
I recommend giving the buprenorphine prior to the incision. The reason being, you want to prevent any sort of pain in the animals and any sort of wind-up pain that could occur. By giving the buprenorphine earlier, you give, or any analgesic, you give that analgesic time to take effect prior to causing any sort of painful stimuli. In my particular procedure, we did give the buprenorphine prior to the first incision. We used, again, this is particular to my study, we used isoflurane, so the animals woke up quite quickly from the end of their study. And giving the pain medication at the time of closure wouldn't have allowed the buprenorphine to have any time to take effect prior to already causing the painful stimuli of the surgery. So I always recommend giving an analgesic prior to making an incision in mice.
Okay, great. Thank you so much for your responses to all of those questions. I don't have any more questions here in this queue, and if there are no more, I'd like to once again thank you. Well, sorry, nope, not thanking you yet. Okay. One more question. In your opinion, could you please comment on whether the use of non-opiates are efficient in terms of providing analgesic relief? And again, I think this is within the context of the surgical model that you used.
I'll start by answering in general. Non-steroidal anti-inflammatories or other non-opioid drugs can be efficient. You really have to consider the surgical model that you're doing and the type of pain that you may be inducing. So as I had stated a little bit earlier, non-steroidal anti-inflammatory drugs are really good for inflammatory types of pain. So just an incisional pain or something that's more of a minor procedure, non-opioid drugs would cover that sort of procedure. When you start getting into deeper or more of a visceral pain, the example non-steroidal anti-inflammatory drugs I don't feel are sufficient, and there have been studies showing that more potent analgesia is needed for some of those more intensive surgeries. So it really depends on what your surgery is. For my study, anecdotally speaking, the lab I was working with had felt that the animals displayed more painful signs when they weren't using an opioid drug. So they were very adamant on using a type of opioid to try to alleviate as much pain as possible in that particular sepsis model.
Well said. Now, if there are no more further questions, I would like to thank you once again for your presentation. Did you have any final comments?
Oh, I just want to thank you all again, especially if anyone's on the west coast of the states. Thanks for waking up and listening to a talk on buprenorphine. But thank you to everyone who stuck around and listened.
And thank you to the audience for joining us today, as Dr. Herndon mentioned, and for all of your very interesting questions. I am having a few more trickles, and we still have a little bit of time. Dr. Herndon, would you like to take them?
Sure.
Okay. I have two more here, and I'm going to have to perhaps cap it after these two questions. If there are any other questions, please try to get them in the next 3 to 4 minutes or so. The first of this next set of two questions is, how do you feel about giving ketoprofen and buprenorphine in conjunction?
So I'm assuming this is for the sepsis studies.
I think I would agree with you. We are going to interpret it as within the constraints of the surgical model employed.
So with ketoprofen, there have been studies that show that some anti-inflammatories do have an effect on sepsis studies. And because a lot of sepsis studies are looking at anti-inflammatory cytokines, by giving an anti-inflammatory drug, you could easily affect those parameters. So for that, there's been a lot of literature really against the use of anti-inflammatory medications in that particular study. In other studies, again, you have to consider what your surgical model is and see if that would have an effect on what the study is trying to prove.
Okay, and I have another one. In your opinion or experience, have you noted a link between buprenorphine and self-trauma?
In my experience, I have not. Most of the studies that I looked at also, if they were looking specifically at wound licking, the main time that you'll see wound trauma is initially after the surgery. And I mean, this is completely my opinion, but an animal that recently had surgery, if there's any sort of residual antiseptic there, or if you used, say, wound clips or surgical glue or sutures, it's new and the animal's going to be interested in it. And so there is a little bit of attention paid to the wound site after surgery, regardless of what analgesic you give. However, after the initial interest in the wound site, I have not noticed any increase of wound attention or attention paid towards the wound using buprenorphine.
Excellent. And then my last question here, which I think will be the last question of this session, is not in relation to the surgical model you employed, but to another surgical model, and it's more geared toward general analgesics as a whole. What analgesic would you recommend for stereotactic surgeries?
Okay, so stereotaxic work, which is always interesting. Let's see. The things that I've seen most commonly employed that seem to work for the researchers here, giving a local analgesic, so giving something like bupivacaine or lidocaine prior to making an incision, if they're actually going to make an incision over the scalp. And I've also seen the use of nonsteroidal anti-inflammatory drugs like carprofen as well as buprenorphine in conjunction. And that multimodal analgesia seems to really help out the animals that are undergoing stereotaxic work.
Excellent. That is it of all of our questions. I'm capping it now. Again, thank you, and thank you to the audience for creating a generous discussion. I'd also like to thank LabRoots today for our educational webcast. This webcast can be viewed on demand through May of this year. LabRoots will alert you via email when it's available for replay. We encourage you to share that email with your colleagues who may have missed today's event. I'll see you next time here at labroots.com. Goodbye and be well.